been one of the hottest movies of the spring, and whether you're a fan of the classic or the new and not so improved version, the idea is still the same. In the near future, scientists merge human tissue with cutting-edge technology to create an advanced unit to improve the lives of the citizens of Detroit. Well, the near future is here, and it's not just the citizens of Detroit who benefit. New Scientist, December 11, 2013 states that advancements in the field of biomedicine and technology has made it possible for scientists to create biobots, or tiny biological robots. And the latest choice for human tissue to merge with technology is, well, unique, giving us what researchers are now calling RoboSperm. This cyborg sperm isn't exactly fighting crime, but Discover Magazine, December 12, 2013 states that it can be used to improve human fertility, battle cancer cells, and target drug delivery to diseased parts of the body. Wow, I definitely buy that for $1. So let's swim into the world of RoboSperm. First, we'll discuss the development of the biobot which inspired the RoboSperm. Then we'll understand how the RoboSperm works, before finally, racing ahead of the pack, discuss some implications and applications of these tiny micro-machines. Before we discuss the advances of this high-tech sperm, let's examine how the concept originated with biobots. Humans have incorporated advanced technology into our bodies for centuries. Hearing aids, contact lenses, and artificial limbs are all examples we see on a daily basis. Even dentures date back to the early Romans. Yet, as Applied Chemistry, December 23, 2013 reports, biobots are a more recent development from the 1960s. Biobots combine both machine and human cells to create a new organism. They were initially modeled after single-celled creatures with long tails. But as noted in Science Daily, January 17, 2014, advancements in the field of biomedicine and nanotechnology have given way to the innovation of new cybernetic organisms. At the University of Illinois, Professor Taher Sahi has led a team of engineers to create tiny biohybrid machines. The body of the biobot is made of flexible polymer with human heart cells cultured at the junction of the head and tail. These heart cells align themselves and begin beating together, creating a wave-like movement down the body of the biobot which propels it forward. According to New York Times, September 17, 2013, biobots were the first synthetic structures with the ability to travel through the human body on their own. However, as a previously cited Discover Magazine reports, biobot research has had its limitations. Most current biobots have proven ineffective, and sometimes even toxic. One of the major challenges is finding a source of fuel that is safe enough to allow the biobot to swim through the human body. Additionally, it is not easy to control where the biobots go. So, there is a danger that the machines can pass through human cells and affect their function. Since this was starting to sound like a Terminator style ramage to our bodies, scientists have recently begun to look for better and safer alternatives. So now that we understand how biobots work, you might have caught on that these biobots seem a lot like sperm cells. Well, we have the technology, so let's now investigate how scientists have rebuilt them into RoboSperm. Professor Oliver G. Schmidt, the director of the Institute for Integrative Nanoscience, tells Gizmag, January 14, 2014, that given the limitations of biobots, his team posited that a powerful biological motor could do the job instead. It was here they turned to one of the body's best engines, the flagella of a sperm cell. And so, the idea of the RoboSperm was conceived. New Scientist, December 11, 2013 states that sperm cells are an attractive option because they are harmless to the human body, do not require an external power source, and can swim through viscous liquids. To create these sperm bots, The Independent, December 10, 2013 states that researchers made microtubes from iron and titanium nanoparticles. The tube is tapered like a cone so that one end is slightly more narrow than the other. These tubes are then added to a fluid containing thawed whole sperm. Sperm cells that swim into the wider end become trapped head first, with the flagella or tail still free to move and navigate. These tubes are a lot like woven finger traps. Once the sperm goes in, it can't back itself out. Sorry, the pull-out method doesn't work. Once the newly formed robosperm are trapped, the true innovation is that scientists can move the sperm box in whichever direction they want. The previously cited Huffington Post claims that robosperm can be used with magnets to be guided and directed in whichever direction they want. And they move pretty darn fast. The previously cited Gizmag also observes that robosperm can swim up to 100 micrometers per second. For perspective, that's equivalent to a 6-foot-tall human swimming a 50-meter pool in only 14 seconds. Wow, we knew our little swimmers were good, but with the technology boost, they're breaking world records. But laughs in the pool aren't all that robosperm are good for. So now that we understand how they work, let's examine some applications and implications of these tiny travelers. First, robosperm can travel far in the field of medicine. The previously cited Huffington Post claims that robosperm could be a highly effective drug delivery system. For example, one of the shortfalls of current chemotherapy is that it attacks both cancerous and healthy cells. A robosperm, however, could be used to deliver drugs and be directed magnetically towards only cancerous cells. Nanotechnology News, January 19, 2014 notes that robosperm can be equipped with stem cells or genetic therapy to treat a wide variety of diseases. Additionally, in the Daily Mail, December 11, 2013, Professor Schmidt envisions using magnetically guided sperm cells to target and fertilize an egg. And with magnetic guidance, the in vitro fertilization process can actually be done in utero. Since the New York Times of September 17, 2013 notes, in vitro fertilization process is expensive with a 70% failure rate. Any improvement in our fertilization techniques will result in many more happy parents. However, there is one significant concern with the use of nanotechnology in humans. The journal Medical Ethics, Winter 2013 notes that nanomaterials raise safety concerns that they can travel to places other than their intended targets. This could cause damage to body tissues or result in other long-term negative effects. With robosperm, what happens to the metallic nanotubes once the sperm are released is a significant hurdle. Researchers will have to develop a way to allow the material to dissolve inside the body. There will also be ethical questions regarding interfering with fertilization that might allow for sex selection or other eugenics-like experiments. These issues must be further addressed before robosperm can make a splash on a greater scale. So today we travel to the future where a man, or at least a part of him, and machine are one end coming to a body near you. First, we discussed the development of the biobot, which inspired the robosperm. Then, we understood how the robosperm works, before finally discussing some sticky implications of these tiny travelers. We're still a long ways off from cyber police officers patrolling our streets, but the concept of combining human tissue with technology is a reality that's inspiring scientists to turn ordinary sperm cells into machines that can make a difference.